Let's look at 5.3 part 2. We're on page 13 in your notes. So, thinking about the graphs of our function f of x and its derivative. Okay, remembering that derivative is the slope of the tangent line to the graph. Okay, so number one, where f of x is increasing, the tangent line will have a positive slope. So the graph of f derivative of x will be positive in those places. When a graph is positive, it means it's above the x-axis. And similarly, where f of x is decreasing, okay, the tangent line there, when it's decreasing, will be negative. And so the graph of the derivative of x will be negative or below the x-axis. Also, if we think about it, wherever f of x has a critical number, that means it changes from increasing to decreasing, or in another case, decreasing to increasing. If there's a critical number, at that spot, the derivative has a 0. So for example, in this little graph, we can see that right here will be a critical number, and the tangent line there we know will have a slope of 0. So when we graph the tangent, this spot will be a 0 on that graph. When we think about it too, where f of x has a constant slope, if it's linear, then the graph of the derivative of x will be a constant, and that should have a t on there. Okay, let's explore these with some examples. Okay, so here f of x is a linear function. You can use y equals mx plus b here, and if we would write a b in, we could say plus 0. The m in this case is 4/1, the slope. Okay, pause it, graph that, find the derivative, and graph it. Okay, so here's the graph of f of x. We had a y-intercept of 0 and a rise of 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. Okay, and I connected those dots. Okay, and then which equals 4. And when we graph the constant 4, we get this. Okay, so it makes sense. The slope of the original function f of x is a constant of 4. We know that the derivative is the slope of the tangent line. The slope of this tangent line is always 4. Okay, moving on. This is a quadratic. We can see that it's written in this form. We know that it's a parabola that opens down because a is negative, and we can tell that its vertex is at h comma k, which in this case is 2 comma negative 3. So we can plot that. We already said it's opening down, and we could figure out the y-intercept pretty easily by putting a 0 in for x. When we do that, we know we have a y-intercept at y is equal to -7, so that the point 0 comma -7 is on the graph. Okay, go ahead and graph that quadratic equation, and then simplify this equation so that you're able to find its derivative. Okay, go ahead and pause and do that. Alright, so here's a sketch of the parabola that's created by that quadratic. Hopefully you were able to graph the same thing. And then I multiplied the y equation out and took the derivative to be this. Now we can see that the derivative is a linear function. We'll do that in red. And when if I graph it, I get a y-intercept of 4 and a slope of -2/1. Okay, and I also noticed that this grid had moved, so I put it back in the right place. So yours should look like this now. Now let's look at what this means. So we can see here that at this critical point of f of x, when we know that the derivative will be 0, right, because the tangent line here will have a slope of 0. The derivative of 0 is 0, and it's shown right here. You can see that there's a 0 here. Another thing we can see is that on this half of the f of x, the tangent line will be positive, right? It's increasing here. And we see that on this half of the derivative graph, it is a positive, meaning it's above the x-axis. Likewise here, where this function f of x is decreasing, we can see that the derivative is negative, or below the x-axis. At this point in the classroom, I would ask for questions, and there might be a few that would clarify it for many of you. If you're at this point in the video and you have a question, text me, like right now. Okay, you can pause and text me. Otherwise, let's move on to example number 3. Here we can see we're graphing a root function that should, in your mind, you can be picturing back to Unit 2, all those yellow or orangish yellow papers we had on the wall and how to graph all these different functions. If you need to, go ahead and look back in your notes. You can draw this graph, f of x, the root function of the cube root of x, and then you can find its derivative and graph that. Press pause now, and I'll do it as well. If you need help, I'm going to explain it in a minute. So you can set up a little table of values if you don't know how to graph it, and the shape will be something like this. Now we can imagine already a tangent line to here. This tangent line, or we can see that this whole graph of f of x is increasing. So the graph of the derivative should all be above the x-axis, should all be positive, because we know that the slope of the tangent line anywhere on f of x here will be positive. We can see that there's no critical points, right? Although, let me think of this, we will have a critical point here. Now, it's hard when I've drawn it, but the tangent line at 0, the tangent line will be vertical. And so we do have the one critical point where our derivative will not exist. And when that happens, we'll see that there's going to be an asymptote right there. Okay, so let's find the derivative, and if you need to, set up another table of values and draw that. Okay, after doing the work, what we talked about is shown to be true. Here's the derivative, and we can see that x can never be 0, so that asymptote happens at x equals 0, right there where the tangent of the f of x does not exist, or is vertical, sorry. I set up a little table of values, just tried 1 and -1, and you can see those green points. And we can see this is a rational function, and rational functions have graphs like that. And you'll see also the derivative is always positive, which we can see with the original, the red one, f of x, that it's always increasing. So the derivative should always be positive or above the x-axis. Number 4 you can see is a rational function. Again, you can look back if you don't remember what a rational function looks like. We can see that f of x will have a vertical asymptote at x equals 3. We also know that there will be a horizontal asymptote because it's a rational function, and you can see that the value or the degree of the variable is higher in the denominator, so that the horizontal asymptote then will occur at y is equal to 0. Sorry, this is supposed to be an at. Okay, so we can draw those on, pause it, and do that. So to figure out where, you could create a table of values again. You could just look at its signs, analyze the sign of that factor in the numerator and the denominator. We can see that at 3 there's going to be an asymptote, or that value of that binomial will be 0. If x is greater than 3, say 4 or 400 or whatever, it'll evaluate positive, and when x is less than 3, that function will evaluate negative. So we can see here that above 3, this is 3 right here, the function is going to be in this area, and if x is below 3, it's going to be negative in this area. So we've got, and you can figure this out if you want, that point is going to be on there. Something like this. Whoops, it should have been through here. Okay, that's a rough sketch of f of x. All right, let's pause it. Well, actually, let's have a look at this first. You can see that this function, if we consider moving left to right, we can see it's decreasing. Yes, it has an asymptote, but here also decreasing. I can see that any tangent line to this function is going to have a negative slope. Okay, this function is always decreasing. So when we do graph the derivative, we will find, or we should find, that the graph of the derivative exists below the x-axis. Okay, because this function is decreasing everywhere. Okay, go ahead and pause it, find the derivative, set up a table of values if you want, and graph it. Alright, so here's the derivative. We can see from just looking at this that the answer will always be negative. We've got squared in the bottom and then we've got multiplied by a negative. So that should be true. That's what we decided. This function is always decreasing, so our derivative should always be negative. It'll always be below the x-axis. As far as asymptotes go, we can see that x cannot, there's a vertical asymptote here at 3, the same asymptote as the original function, and also the same horizontal asymptote at y equals 0. I just did a small table of values, and you can see that 4 and -1 is going to be on the graph, as well as 2 and -1 right here. So our rational function of the derivative, a sketch of it is in blue. Okay? If you want to look in your textbook for example 5, or on page 235. It is also pictured if you turn your page right here. Okay, so 235, your turn. It says one of the graphs below is that of f of x, the original function, and the other graph is that of its derivative. Which is which? Pause it here and see if you can rationalize it, and when you unpause it, I will tell you. Yeah, you need to pause. You forgot to pause. I don't want to just tell you the answer. You have to think about it. Okay, I will tell you that number 1 is the derivative of x. That's a mess. And number 2 is the original function, f of x. How do we know this? Okay, the critical point on graph number 2 is right here, where this function turns from increasing to decreasing. That critical point we know has a tangent line of 0. So when I look at which is the derivative and which is the original, I can see that this critical point should have a 0, which it does right here. That's a 0 means where it crosses the x-axis, or where y happens to be 0. So that means that the dashed function, number 1, should be the derivative. Another way we can, or another thing we can look at is we can see where one of the functions is increasing, then its derivative should be positive. So again, when we look at number 2, from this point all the way to the critical point here, this function's increasing. So the derivative should be positive or above 0, which it is. Here, after this critical point, or the function number 2 turns to decreasing, and you can see that at this point 0, it goes below the x-axis, and the derivative is negative. Okay, so you can move on to your assignment. Good luck with this, and again, if you need help, please text or Gmail.